Now we're going to look at some problems where we are going to have to isolate the absolute value before solving the inequality. These are both less than inequalities. So let's go ahead and isolate that absolute value. I'm going to start by adding 4 to both sides. Divide both sides by 8. And now I can use that trick that we learned earlier about less than inequalities. We know that x is going to be between 3 and negative 3 inclusive. So if we have 0, 1, 2, 3, negative 1, negative 2, negative 3, x is going to be in between and including these positive and negative 3's. Writing that in interval notation, we're going to use hard brackets because we can include negative and positive 3 in our solution. In the one below, again, we're going to have to isolate that absolute value. So I'm going to start by dividing both sides by a negative 4. Now remember what happens when we divide by a negative. We're going to have the absolute value of x plus 5, and we have to flip the inequality. Now we have a greater than. So we're going to have to take x plus 5 is greater than or equal to 2, or x plus 5 is less than or equal to a negative 2. Subtract 5 from both sides and we get x is greater than or equal to 7. And on this side we'll subtract 5. Sorry, that's a negative 3. This one will be x is less than or equal to a negative 7. We'll go ahead and graph these. Let's see, negative 3, 4, 5, 6, 7. Solid circles. X is greater than or equal to a negative 3, less than or equal to a negative 7. Let's write that in interval notation. The smallest number we cannot include is negative infinity. We can go up to a negative 7 and include that negative 7. Do a union, hard bracket on negative 3, all the way up to infinity, soft brackets.